The role of AI in enhancing predictive maintenance for spacecraft and the International Space Station. Artificial intelligence, or AI, has become a game-changer in predictive maintenance, leveraging its ability to process and analyze vast amounts of data with unprecedented speed and accuracy. Its prowess in this field stems from its capability to learn from historical data, identify patterns, and make forecasts about future conditions. This is particularly crucial in the context of spacecraft and space stations, where failures can be catastrophic due to the harsh and unforgiving environment of space. By using AI to monitor and predict potential issues, we can significantly enhance the reliability and longevity of these complex systems. This essay explores how AI improves predictive maintenance for spacecraft and the International Space Station, the broader implications for humanity and the sciences, and the future potential of AI in space exploration. AI in spacecraft health monitoring. Spacecraft are exposed to extreme conditions in space, including temperature fluctuations, radiation, and microgravity, all of which can impact their performance. Predictive maintenance, facilitated by AI, is vital for ensuring the health and functionality of spacecraft throughout their missions. Real-time monitoring and data analysis. AI-powered systems can continuously monitor spacecraft health by analyzing data from numerous sensors embedded throughout the vehicle. These sensors track various parameters such as temperature, pressure, vibration, and electrical currents. AI algorithms process this data in real time to detect deviations from normal operating conditions, identifying potential issues before they escalate into critical failures. Early detection of wear and tear. One of the most significant advantages of AI in predictive maintenance is its ability to detect subtle signs of wear and tear that might be imperceptible to human engineers. By analyzing patterns and trends in the sensor data, AI can identify early warning signs of component degradation or malfunction. This early detection allows for timely interventions, reducing the risk of mission failure and extending the operational lifespan of the spacecraft. Proactive maintenance scheduling. AI can optimize maintenance schedules based on the predicted wear and tear of spacecraft components. Instead of relying on fixed schedules, AI systems adjust maintenance activities dynamically, based on real-time data and predictive analytics. This approach ensures that maintenance is performed only when necessary, minimizing downtime and avoiding unnecessary service. Enhanced fault diagnosis. When issues are detected, AI systems can assist in diagnosing the root cause of the problem. By analyzing historical data and comparing current conditions with past failures, AI can identify the specific component or system that is likely to be malfunctioning. This precise diagnosis facilitates more effective repairs and reduces the time required to resolve issues. AI in the International Space Station, ISS. The ISS is a complex and multifaceted environment where predictive maintenance is crucial for maintaining safety and operational efficiency. AI plays a significant role in managing the numerous systems and components on the station. System monitoring and integration. The ISS houses a wide array of systems, including life support, communication, and scientific equipment. AI systems integrate data from these diverse sources to provide a comprehensive view of the station's health. By continuously monitoring all systems, AI helps ensure that the ISS remains operational and safe for its crew. Maintenance optimization. The ISS's maintenance schedule is optimized using AI to ensure that all systems are functioning correctly and to address potential issues before they impact the station's operations. AI can analyze data from various subsystems to predict when maintenance tasks should be performed, balancing the need for preventative upkeep with the constraints of crew time and resources. Fault prediction and management. AI aids in predicting faults and managing potential problems on the ISS. For instance, AI algorithms can analyze data from the station's environmental control systems to foresee potential issues with life support. Early warnings enable the crew to address problems proactively, minimizing risk to their safety and the station's functionality. Crew support and training AI also supports the ISS crew by providing real-time diagnostics and recommendations. In the event of a malfunction, AI systems can guide astronauts through troubleshooting procedures and offer solutions based on historical data and predictive models. This support is invaluable in space where crew time is limited and mission success depends on efficient problem solving. Impact on humanity. The integration of AI into predictive maintenance for spacecraft and the ISS has several implications for humanity, both directly and indirectly. Improved space mission safety. By predicting and preventing potential failures, AI enhances the safety of space missions. This increased reliability reduces the risk of catastrophic failures, contributing to the overall success of space exploration efforts and protecting both human lives and valuable scientific equipment. Extended mission lifespans. AI-driven predictive maintenance can extend the operational lifespan of spacecraft and space stations. By proactively addressing wear and tear, AI helps ensure that these systems remain functional for longer periods, enabling more extensive and ambitious missions. Cost efficiency. Predictive maintenance powered by AI can reduce costs associated with unplanned repairs and downtime. By optimizing maintenance schedules and avoiding unnecessary interventions, space agencies can allocate resources more effectively, potentially leading to cost savings and more efficient use of funds. Technological advancements. The development and application of AI in space maintenance drive advancements in technology. The techniques and algorithms used in space missions can have broader applications, benefiting other industries and leading to innovations in fields such as manufacturing, transportation, and infrastructure. Impact on the sciences. AI's role in predictive maintenance has significant implications for scientific research and development. Enhanced research capabilities. Reliable and well-maintained spacecraft and space stations contribute to more successful scientific missions. By reducing the risk of equipment failures, AI enables scientists to conduct experiments and gather data with greater confidence, leading to more accurate and comprehensive research outcomes. Advancements in AI techniques. The challenges of predictive maintenance in space environments drive advancements in AI techniques and methodologies. Innovations developed for space applications can be adapted for use in other scientific fields, fostering cross-disciplinary research and technological progress. AI's ability to analyze and interpret complex data contributes to a deeper understanding of spacecraft and space station systems. These insights can inform the design and development of future space missions, improving the performance and reliability of new technologies. The application of AI in predictive maintenance encourages collaboration between experts in various fields, including engineering, computer science, and space science. This interdisciplinary approach leads to more holistic solutions and drives progress across multiple domains. Looking ahead, the role of AI in predictive maintenance for spacecraft and the ISS is likely to expand, with several potential developments. Advanced predictive models. Future AI systems may incorporate more advanced predictive models using techniques such as deep learning and reinforcement learning to improve accuracy and adaptability. These models could enhance the ability to foresee and prevent potential failures with even greater precision. Autonomous maintenance systems (AI) may enable the development of autonomous maintenance systems that can perform repairs and adjustments without human intervention. These systems could further reduce the need for crew involvement in maintenance tasks, allowing astronauts to focus on other critical activities. Integration with other technologies. AI-powered predictive maintenance will likely be integrated with other emerging technologies such as robotics and nanotechnology. This integration could lead to more sophisticated maintenance solutions, including automated inspections and repairs. Broader applications. The advancements in AI-driven predictive maintenance for space missions may find applications beyond space exploration. Techniques and technologies developed for spacecraft and space stations could be applied to other high-reliability industries such as aviation, critical infrastructure, and industrial automation. Conclusion. AI has significantly enhanced predictive maintenance for spacecraft and the International Space Station, offering improvements in real-time monitoring, early detection of issues, and proactive maintenance. Its ability to analyze large volumes of data and make accurate predictions has profound implications for mission safety, operational efficiency, and cost management. The impact on humanity and the sciences is far-reaching, contributing to safer and more successful space exploration, driving technological advancements, and fostering interdisciplinary collaboration. As AI technology continues to evolve, its role in predictive maintenance will likely expand, offering new possibilities for maintaining the reliability and functionality of space systems and beyond. Please like and subscribe to my channel for more to come.